Okay, this lesson is all about function operations. You'll see what a composite function is here next, which we're going to work with that as well. And you're going to see a lot of different notation for this. It all depends on what book you're looking at or website or whatever. This just means distribute, and you're going to be doing g of n times h of n. Now take note, there's something that looks very similar to this that means to do something different, and that's going to be on the next slide, so pay attention to that. So this just simply means take your g of n and multiply it by your h of n, function operation. So we'll do n squared plus 4 plus 2n times negative 3n plus 2. At this point, we should be pretty good and know that we have to distribute everything from here to everything here. So distribute that, and that's basically n squared times negative 3n. Actually, if you want, you might as well pause the video, multiply it out yourself, and make sure you can multiply it well. If not, then watch through it. And then n squared times 2. Notice I'm distributing the n squared. Now I'm going to distribute the 4. Whoops, so it's going to be 4 times negative 3n. And then 4 times 2, and then I'm going to do 2n times negative 3n, and then 2n times 2. So multiply all of that, we'll get negative 3n cubed plus 2n squared plus negative 12n plus 8. And I'm going to write into this, but no big deal, plus negative 6n squared, because negative 3 times 2 is negative 6, and n times n is n squared, plus 4n. Then we're going to combine all of our like terms.
Excuse the interruption. Would all 8th grade girl track and field athletes please meet in Coach Witowitz's room, 502? Oh, girl 8th grade track athlete.
Okay, so there's my like terms there. Here's my negative 12n and positive 4n, leaving me with negative 8n, and then I bring down my plus 8. So g of n equals n squared plus 4 plus 2n times h of n, which is negative 3n plus 2 equals, so g times h of n equals negative 3n cubed minus 4n squared minus 8n plus 8. Okay, so we have that. Let me clear this. So that is essentially what this slide is all about, doing the operation. So this is f of x minus g of x. So with this, order matters. So you have to do 4x minus 3, and then minus x cubed plus 2x. Notice how when I lined it up vertically, I didn't put x cubed under anything because it doesn't have a like term. So I'm basically doing 0 minus x cubed, which is negative x cubed, and then 4x minus 2x, and that's 2x, and then negative 3 minus 0 is negative 3. So f minus g of x is negative x cubed plus 2x minus 3. Okay, good. For the rest of these, maybe not this one because you might struggle with it a little bit, but why not this one? Why don't you pause the video, why don't you try to do that one, set it up, try to do it, make sure you understand what you're doing here, and then watch the video or fast forward it to that answer so you can see where it's at. And then this one I'll talk about. So this here, again, we're just going to do some operations with functions. And this means h of x plus g of x. Okay, so you need to add them. So it's going to be 3x plus 3 plus negative 4x plus 1. Add that, and you have negative 1x plus 4. Done. This one here, like I said, it's a little bit different because we're doing 3x minus 1 divided by x squared minus x. So really, the 3x minus 1, if we did long division here, the 3x minus 1 would be inside, and the x squared minus x would be out. And there's nothing I can multiply x squared by to have it equal 3x. So because we can't divide it that way, then we have to say, all right, well, can I simplify this by factoring? Can't factor the numerator, the denominator, you could factor an x out, and so then you would have x minus 1, and that's, you still can't cancel anything out. Well, you might say, well, there's an x minus 1 here. Not really, there's a 3x minus 1. It's not the same group. So really, there's nothing we can do to divide that. So that's it, that's simplified. Now, if we could divide it, obviously you're going to have to, whether it be factor the numerator and denominator and cancel, or it might, you could use long division. Depending on the divisor, you might even be able to use synthetic division. In this case, we couldn't, because it's an x squared. You can only use synthetic division with linear problems. We'll see more about composite functions on our next slide.